Okay, today we're going to talk about angles, pretty common geometric concept, and something you certainly all have had some familiarity with throughout your life. But we'll maybe put a little bit more of a formal slant on it, provide some vocabulary that we're going to use in the future. So right here we've got the 1-4 note sheet, which talks about angle relationships, angles, and their measures. So as far as constructing an angle goes, we want to think about having a point that's going to serve as a very special locator. And from there, we're going to come off and create two sides of our angle. This particular point is going to be called the vertex of the angle. Let's give it a letter. Let's call it V, or vertex. Now, what you see here in this question about what geometric parts make up an angle, essentially what we have are two rays that come out. So we've got this ray over here and then this ray here that both project from point V, which is our vertex. So why don't we put a point over here, and we'll maybe call this point A and this point here B. So we have the ray VA and a ray VB. So they're two rays with a common endpoint. So as far as the geometric parts, we would say two rays with a common endpoint. And how we're going to name that angle is going to be specific to points that we choose on each ray and the vertex. But the key thing that we're going to have to realize here is the vertex is always going to be the middle of the three letters that we indicate. So for this one, we might call this guy angle AVB as we proceed from point A to point V to point B, and it kind of creates that angle. Equivalently, we could call this angle BVA. Okay, but it's important that the V occurs, the vertex occurs as the middle letter. The other way we can do this is we can put like a little number in here and just refer to this as angle 1. But of course, then we'd have to indicate that by showing that there's a 1 there. So you'll see both of those techniques for naming angles as we move through the year. When it asks us to shade the interior of our angle, we're going to be talking about the space between the two rays inside here. So that's what we consider the interior of an angle. And plot one point on the interior of our angle. So we could plot a point in here somewhere. Oops, that looks a little funky. Let's get our pen and plot one there. So we could maybe call that point, I don't know, X. So we could say X is the point that we plotted that's in the interior of our angle. And then anywhere that is not shaded, we could come out and plot a point out here, call that point Y. Y is a point that is in the exterior of our angle. Now, when you take a look at this picture below, what type of angle is pictured below here? And everybody says, oh, it's going straight up and straight over. This is a right angle. So, of course, you look at bullet point 7 says, if you said right angle, you're wrong. We cannot assume that an angle is a right angle in our study of geometry unless it's indicated as such using that little notation there, which indicates that that measure of that angle is 90 degrees, which, of course, is a right angle. And that's how we're going to know it. So how something's truly a right angle, we better see that notation there. Or we better have enough information available to us that can lead us to conclude that that measure is 90 degrees. But of course, the measurement of a right angle is 90 degrees. That's nothing new to anybody. So as we move forward here, we take a look at the diagram shown below. All of these angles have measures. You know, this guy here is 54 degrees and 12 degrees, 48 degrees. And we're going to use the vocabulary that an acute angle is any angle whose measure is between 0 and 90 degrees. And similarly, an obtuse angle is an angle whose measure is greater than 90 degrees. So all these angles up here have angles that are, or measurements that are less than 90. So these would all be considered acute angles. And of course, down here, the second batch of angles 116, 112, 168, 94, and so forth. Those are all greater than 90, so we're going to call those obtuse angles. So just a little vocab that we can use as we move forward in our angle descriptions. Now, if you have an angle that measures exactly 180 degrees, what we're going to see is that that measure is 180 degrees. What we have is a line, and so we're going to call this a straight angle. okay, which is pretty much kind of the basis for some of the study we're going to do as we move forward into the rest of our study of angles, but as we get into things like parallelograms that exist in certain types of polygons, we're going to use this idea of a straight angle. Once you go beyond 180 degrees, so for example, if I take something and I rotate out this way, if I go to 180 degrees, that's fine. But if I go even beyond 180 degrees, and I come down like that, what we're going to tend to do is look at this angle over here on this side, which is less than 180 degrees. But let's draw an acute angle. So we come over here, we draw one that's less than 90 degrees. And let's say that this guy is, let's say that's 50 degrees there. Instead of measuring that interior angle of 50 degrees, imagine measuring this angle that's going around the exterior, so this guy here, and that's known as the reflex angle. It doesn't get used a whole lot, but it's nice to have a name for it. And we could figure out its measure if we just understand that all the way around a circle is 360 degrees, and since our reflex angle that we're showing here is on its way all the way around the circle, but we stop 50 degrees short, I think it stands to reason that that measure of that angle would be 360 minus 50, which is 310 degrees. So that guy would measure 310 degrees. So we can consider angles that are greater than 180, and we're going to do a whole bunch of that when we get into our study of precalculus and trigonometry. So of course I've now laid the groundwork for what we would consider a complete or a full angle is when you start with one ray here that's going out from the center, and then the second ray, as we rotate, we go all the way around onto this thing and we come back right to where we started, and our second side, the other ray, lies right on top of the first one. And of course the shape that we've kind of made here is just a ray that's shooting out to one side. So it's just kind of a unique special situation of a 360 degree angle. So we want to talk about how angles get measured, and to do this the fundamental tool is a protractor, which you can see is one of these plastic shaped, you see these all the time in middle school, plastic kind of semicircular shaped objects with the numbers from 0 to 180 across the top, and then going backwards from 0 to 180 across the bottom. And of course, if we had an angle that we wanted to measure, something like this guy over here, the way to use one of these guys is to notice where the vertex is, and we would align that with the center point right here, which would be the center of this circle that goes all the way around. So I can't physically move this circle. I can't physically move this angle over here, and I can't move the picture of the protractor over there. So I'm just going to kind of redraw it and imagine that we had an angle that was coming out here and out there somewhere. And all you would do is simply, since we're going to consider this to sort of be our home base side, and in trig we would call this the initial side of this angle, and then we rotate it up through 10 degrees, 20 degrees, 30 degrees, and it looks like we're at about 37 degrees there, just a few degrees before 40, so we would say the measure of that angle is 37 degrees. Similarly, you could have an angle that's positioned, maybe I'll make him red over here, where it's going this way. Oops, that's a little off. Let's do that again. There we go, something like that. And then we have an angle that's coming up here like this, and you could say, okay, using this as the initial side, and we rotate up that way, we're using the numbers on the outside, 10, 20, 30, 40, 50, 60, 70, and it looks like it's an 80-degree angle right there. So we could come up with lots of different angles and put them in here and go get a protractor and try to measure them all. But we have plenty to practice with right here. So let's just consider maybe one or two of these problems here where we're talking about angle MLN. So remember that middle letter is the vertex, which is right here. That makes sense. So if we're talking about MLN, because M is our kind of where we're starting our initial side, we're going to rotate up and we're going to count 0, 10, 20, 30, 40, 50, and it looks like it's smack dab right there on the 60. So we would say the measure of this angle is 60 degrees. What might be interesting is to do one that's like, maybe angle NLP or something like that, which we have next. And that angle, as you can see, it starts here. If you want to think about it going this way and rotating that way, out to that, we'd say, okay, it looks like it starts at the 60 and it rotates over to 170. So we went from 60 degrees over to, I'm sorry, I think I said 170, 130, which is a distance of 70 degrees. So much like we would find the distance between two coordinates, where if this coordinate was 2 and this coordinate was 12, this was A and B, we would say the distance from A to B is B minus A absolute valued, which is the absolute value of 12 minus 2, which of course is going to be 10. We could think of this the same way. Say our reading here, which is 130 minus 60, absolute value that, you get 70. That way, using the absolute value, it doesn't matter if you did 60 minus 130 or 130 minus 60. Either way, you're going to get 70 degrees, and that's how we can determine that angle. So there's a few more here for us to practice on, but again, most of those are pretty straightforward. Speaking of straightforward, can you name a straight angle? So if you remember from our last slide, a straight angle is one that measures 180 degrees. So going from 0 to 180, it looks like we would name that angle MLQ, or equivalently QLM. So we can put that down here. We'll say angle QLM or angle MLQ.